1017 says most salamanders are red striped, but some individuals are all red. The all red form is thought to be a mimic of the salamander something, which is toxic to birds. In order to test whether the mimic form actually survives more successfully, 163 striped and 41 red individuals of the salamander were exposed to predation by a natural bird population. After 2 hours, 65 of the striped and 23 of the reds were still alive. Use a chi-squared test to assess the evidence that the mimic form survives more successfully. Use a directional alternative and let alpha equal to 0.05. It says state the null hypothesis in words, or I'll just state both hypotheses as part A. So in words, the null hypothesis would be the all red salamander has the same survival rate as the striped form. Okay. Or in other words, color and survival are independent. Okay. But if you wanted to explain this to a normal person who might not be familiar with the meaning of the statistical meaning of independence, probably this form of the null hypothesis would be better. The all red salamander has the same survival rate as the striped form, and the alternative is that the all red salamander has a better survival rate. Survival rate than the striped form, okay? Okay. Part B says state the null hypothesis in symbols. So here I'm going to say P1 is the proportion of striped salamanders that survive and and P2 will be the proportion of red salamanders that survive. Okay, and so the null hypothesis in this case will be P1 is equal to P2, and the alternative is that P1 is less than P2. P2 is the proportion of red salamanders that survive, and so in this alternative we're stating that the proportion of red salamanders that survive is higher than that of the striped salamanders that survive. Okay, part C says find the value of the test statistic and the p-value. So in this case I'm going to clear out this board, and we will have to make our 2x2 contingency table. So we have two populations. We have the striped form and we have the red form. Okay, and then we have those that survived, and if they didn't survive, they died. And so a total of 163 striped salamanders were tested and 41 red. And at the end of the trial, 23 survived, which means that 18 of the red salamanders died, and of the striped ones, 65 survived, which means 98 died. Okay, so these are the observed values. So I'm going to put the expected values in parentheses. So expected, okay, so over here, the total number that died is 88, and the total number that survived is 88, and the total number that died is 116 out of a total number of 204 salamanders. Okay, so that means about 43% survive and 57% die. Okay, so if we do 43% of 163, so I'm just going to do 163 times 88 divided by 204. That's going to be, we're expecting 70.3, I'm going to say 70.31 to survive. And then for the red salamanders, we're expecting 41 times this proportion, so 41 times 88 divided by 204. We're expecting 17.69 to survive. Over here, 163 times this proportion, which is 116 divided by 204. Here we're expecting 92.69 to survive, and over here we would be expecting 41 times 116 divided by 204, 23.31 to survive, or to die. Okay, so maybe I've been saying the wrong words, but we would, if 163 salamanders were exposed, then out of those we would expect 70.31 to survive and 92.69 to die. And what we observed was 65 survived and 98 died. Meanwhile, over here we're expecting, out of the 41, 17.69 to survive and 23.31 to die. So our chi-squared statistic, as always, is observed minus expected squared divided by expected. So we have four numbers here, or four things to add up. So 65 minus 70.31 squared divided by 70.31. And I'm just going across. 23 minus 17.69 squared divided by 17.69. This number, 98 minus 92.69 square over 92.69, plus this last one, 18 minus 23.31 square divided by 23.31. Okay, so quite a few numbers to crunch here, but still doable. So for here we get 0.4010. This number turns out to be 1.594. Here we have 98. 0.304, and the last number 1.209. I'll say 2096. Okay, so I'm going to add all of these numbers up. Okay, and so here we get a total value of 3.509. Okay, 3.509, and our 2x2 tables always have 1 degree of freedom. Okay, so we go to the back of the book, into our table, and we look up with 1 degree of freedom where 3.509 lies. So 3.509 is in between the numbers for 2.71 and 3.84. Okay, so in between these two numbers, 3.84 corresponds to a tail probability of 0.05 and 2.71 tail probability of 10. Okay, that's our tail probabilities, but because this is a directional alternative, remember the alternative hypothesis was that P1 is less than P2, we have to divide by 2 for our p-values. So our p-value is going to be between 0.05 and 0.025. Okay, so it's less than 0.05, bigger than 0.025. So in this case, we reject the null hypothesis. Okay, in words, we say we have evidence to show that the proportion, basically, proportion of red salamanders that survive is higher than P1, which is the proportion of striped salamanders that survive. So our evidence, out of our 204 salamanders, we do have evidence to show that the red salamanders survive at a higher rate than the striped salamanders.